Math 110, Polynomial and Rational Inequalities, Section 4.6. Polynomial inequalities, just like quadratic inequalities, they can be written in the form ax squared plus bx plus c equals 0. A quadratic inequality can be written in the form of ax squared plus bx plus c, where this blank space could be any of these values here. It could be a greater than or less than symbol, or we can have that equal to added to it. Now that symbology is really important because that symbology basically is going to ask us to either find values that are greater than 0 or values that are going to be less than 0. And so values that are greater than 0, if we think about it on a number line, if that's 0, values that are greater than 0 are going to be positive numbers. Values that are less than 0 are going to be negative numbers. And so we need to keep that in mind as we move forward. So our first example here, it says x squared minus 4x minus 5 is greater than 0. So because it says greater than 0, I know I want to look for those positive numbers. Now the first thing that I want to do is I want to solve for this, and I want to find my zeros. So I factored this into x minus 5 and x plus 1, and so my zeros are going to be 5 and negative 1. I take those values and I place them on a number line. Now because it says greater than, there's no equal to, they're both going to have these open circles. Then what I want to do is I want to, step 3, plug in values on either side of my zeros to find true statements, or in this case it's going to be positive or negative statements. So plug in a value on this side, f and negative 2. If I plug that in and simplify it, I get 7. 7 is a positive value. If I plug a value in between negative 1 and positive 5, like 0. Okay, and if I plug 0 into my polynomial and I simplify it, I get negative 5. Negative 5 means that it's a negative value, and we'll say that this represents every number in here being negative. Then plug in a value that's going to be greater than 5, is 7. If I plug in 7, I get 16. 16 is positive, and so this is going to be represented all positive numbers. Now the expression here said, hey, I want a value greater than 0. Okay, that's what this inequality said. I want a value greater than 0. And so I want to shade all my values that are greater than 0. Those are going to be these values and these values here. And so now, step 4, I can write my interval notation to it. Negative infinity all the way to negative 1, union from 5 all the way to positive infinity. Because it's open circle, these are going to be parentheses. So recap on the steps here. First thing that I did, find the zeros. So I set this equal to 0 and I solved for it, and I found that x was 5 and negative 1. Step 2, place the zeros on a number line. So I placed negative 1 and 5 on the number line, and I denoted these being open circle because there's no equal to here. Then I got to plug in values on either side to validate or find true statements. Now another way of looking at that would be, because this is saying I want values that are greater than 0, it's saying I want all positive values. So all my true statements are going to be positive values. So I plugged in a value here, I got 7, so this interval is represented by all positive numbers. I plug in a value here, I plugged in 0, I got negative 5. So this interval represents all negative numbers. I plugged in 7, I got 16. This interval represents all positive numbers. So then step 4, writing my interval notation to represent my answer, I can say that it's negative infinity all the way to negative 1, union from 5 all the way to positive infinity. Now example number 2, I want to set this equal to 0. Right? It has to be equaling or less than or greater than 0. So I'm going to have to subtract x and subtract 3 to both sides. So now looking at this statement here, this says less than or equal to 0, which means that it's looking for negative numbers. So I need to know that moving forward. So now my first step, I want to find the zeros. So I can factor this, set it equal to 0. When I solve for it, I get x equals -4 and +2. Then I'm going to place those zeros on a number line. Notice that these are now closed circles. The reason why these are closed circles is because this says equal to. Now I want to plug in values on each of these intervals here, so on this side of the 0, between the two zeros here, and on this side of the 0, and find those true statements. So plugging in -5, I get +7, so this interval is represented as positive. Plug in a value here, 0, I get -8, so this interval will be represented by negative numbers. Plugging in a value here, 4, plug that in, I get a +16, and so that's going to be represented by a positive value. So then, because I know this statement says all the values that are less than or equal to 0, I know it's asking for all negative values, so that's going to be this interval here. And so now step 4, writing the interval notation of that, that's going to be from -4 all the way to +2, and it's going to have brackets. On this third example here, it's already 0 right there, so it's kind of quote-unquote set equal to 0. But it says greater than 0, so all the values that are greater than 0 are going to be positive numbers. So my first step, find all the zeros, so I need to factor this. So I can factor out an x. Now with this statement here, I can factor it further into x plus 1 and x minus 1. So all my zeros are going to be 0, -1, and +1. Now, step 2, place those values on a number line. They all have open circle because there's no equal to. So now I need to plug in intervals, or plug in values from each of these intervals here. So if I plug in -2, I got -6, so this is going to be negative. If I plugged in a value here, -0.5, I got a positive 0.375, so that's positive. If I plugged a value here, I got negative, and I plugged a value on this side, and I got positive. So now, shading the side that's true, because we said that it's asking for values that are greater than 0. Values that are greater than 0 are positive numbers, so I'm going to be shading this side and this side. So now I want to write the interval notation to represent the answer. So that's going to be from -1 all the way to 0, parentheses because they're open circle, and then union starts again at 1 all the way to positive infinity. Now this one I didn't want to work all the way through it, but just to give you a heads up on this one, to be able to find all the zeros, which is going to be the first step, you're going to have to do all of your p's over your q's. So if you remember the rational roots theorem, my p's are going to be the factors of 4, so 1, 2, and 4. My q is going to be the factors of 3, which is 1 and 3. So my p's over q's are going to be all the combinations. So 1 over 1, 1 over 3, 2 over 1, 2 over 3, 4 over 1, and 4 over 3. And these are all plus or minus, etc., etc., etc. But you'd have to test those zeros, see which one works, and you'd be factoring and breaking it down using my rational roots theorem. But all these other steps apply. Now we're going to be moving on to rational inequalities. Now the way that we solve these going to be very similar. Okay, so we're going to be doing the same basic steps. The only thing that's going to be new are going to be one of our first steps. I'm going to dub finding these important values as critical values. Now critical values are where the expression is not defined. And so tailing that to a previous lesson, those are all the holes in vertical asymptotes. All critical values are going to be considered excluded values, which means open circle. Okay, so you're going to mark all critical values as open circle. So just a recap, the first step we should be doing now is finding critical values when it comes to rational inequalities. All those critical values are holes in vertical asymptotes, and we're going to classify them as open circle. So in example 5 here, it says solve 3x over x plus 6 is less than 0. So because it says less than 0, I know it's going to be looking for negative numbers. So the first thing I want to do, find those critical values. So that's going to be a vertical asymptote here. Okay, so if I set the denominator equal to 0, x plus 6 equals 0, I'm going to get x equals negative 6. So that's going to be my critical value. Now from there, I can find my 0. So if I multiply both sides by x plus 6, I'm going to get 3x equals 0 times x plus 6, which is just 3x equals 0. Divide both sides by 3, you just get x equals 0. Then what I can do is I can take these values, this 0 and this negative 6, and I can place it on the number line. Open circle because there's no equal to, so that's why 0 has an open circle. And then this has an open circle because it's a critical value. So once again, plug in values in each interval. So a value that is less than negative 6, which is negative 8, I got a positive 12, so that's positive. A value in between negative 6 and 0 is negative 2. I got negative 1.5, so that's going to be negative. And then a value greater than 0, I plugged in 3, and then I got a positive 1, so that's going to be positive. This said all the values that are less than 0, which means that are negative values, so I'm going to shade the negative region. And so step 5, writing my interval notation, I get negative 6, 0. This next example here. Now, notice it doesn't say less than 0. So if I go through the process, and we're going to see in a second, if I go through the process to be able to solve for it, we know that eventually this is going to say less than 0, less than or equal to 0 if I subtract 1. Okay, so technically it still says less than or equal to 0. I just haven't gotten to that step yet, and so I know that I'm going to be looking for negative numbers. But here I have a vertical asymptote, so our first step, finding that critical value. If I set that equal to 0 and solve, I got x equals 2. So now, see how I subtracted that 1 there, and then I got this to being a 0. If I had that symbol, less than or equal to, then I would know that it would verify that statement there. So solving for this, I subtract 1 on both sides. Now we said that when we have rational equations, we want all the denominators to be the same. So I multiplied top and bottom by 2x minus 4 and 2x minus 4 on this side. Now 0 times anything is just 0. Negative 1 times 2x is negative 2x. Negative 1 times negative 4 is positive 4. Combine like terms and solve, I get x equals 5. So now I can take these values and I can put them on my number line, which is step 3. My critical value was 2, that's why that's open circle. This was actually my 0 and it has an equal to symbol, so therefore it's going to be a closed circle. So now I test values on each of these 3 regions. If I plug a value on this side, which is going to be 0, I get a negative. If I plug in a value here, which is 3, I get a positive. And if I plug in a value on this side, like 6, I get a negative. So now we know that this says less than or equal to 0, right? If I subtract that 1, so I know it's looking for negative numbers, so that's going to be my shaded region, which is my true statement. So then step 5, writing my interval notation, it's going to be negative infinity all the way to 2, union from 5 all the way to positive infinity. And because this is a closed circle here, it's going to be a bracket. This next example here says solve x minus 3 over x plus 4 is greater than or equal to x plus 2 over x minus 5. So once again, if I had subtracted that statement there, it's going to say greater than 0. And so I know that it's going to be looking for those positive numbers. So the first thing I want to do is find those critical values. It's going to be negative 4 and positive 5. Right? Because those are going to be my vertical asymptotes in this sense. Then find the zeros. So in finding the zeros, if I subtracted that x plus 2 over x minus 5, I have to find the common denominator between everything. So this statement needed the x minus 5, this statement needed the x plus 4, and this statement needed both the x minus 5 and the x plus 4. Well, 0 times anything is just 0. And the other thing is once the denominators are all the same, we don't have to worry about it anymore. We can just get rid of it, right? We don't need the denominator once they're all the same. And so I just get the statement x minus 3 times x minus 5 minus x plus 2 times x plus 4. I can FOIL that together, I can FOIL that together, combine like terms. Okay, and then solving for x, I get x equals 1/2. So now I need to take my critical values and my zeros and put it on the number line, which is step 3. And so now I need to plug in values on all sides to find the true statements. If I plugged in a value on this side, like -5, I get a positive. If I plugged a value in between here, like -2, I get a negative. If I plugged in a value in between here, like +3, I get a positive. And then if I picked a value over here, I get a negative. And so since this is saying values that are greater than 0, I know I'm looking for the positive region here. And so writing my interval notation, it's going to be from -infinity all the way to -4, union from from 1/2 to 5. This is bracket because it's closed circle, and this is open circle, so that's going to be parenthesis. And so this is the answer that I'm looking for. If you have any other questions, please leave them in the comments.